Hello everybody, in this video I will try to explain how to solve a more complicated circuit, even it's very simple, but more complicated compared to the previous one that I told you. So we have here more than one mesh, basically. So let's look at the circuit and identify first of all how many meshes and which are them. We have actually three meshes here. One mesh is this one, another one is this one, and the third one is the big one, this thing here. This is just because of the definition of mesh. A mesh is a closed circuit, so I can start from one point and I come back in the same point by following the circuit. So let's write down the current of this circuit. So here I have a current, I call it I. This current I goes here inside, then is split into two in I1 and I2. I1 continues on this direction, goes here, come back, and then I2 and I1, they combines back into I. So from this point and this point, I can write down this equation. Basically, I state here that I splits into two current, smaller, I1 and I2, from this node and this node. Okay? Okay, now I will write down the voltage drop caused by the flow of this current here in the circuit. And I will write down this voltage drop following Ohm's law, which is basically this thing here with this convention. If the current goes into the plus terminal, V equal R times I. Okay, with all positive sign. Okay, so I will have here a voltage drop on R1 with this sign, plus where the arrows enter the resistor. Then on this branch, I will have a plus here and a minus here. So I have plus, minus. Here, same. I will have plus here and minus here. And finally on R2, I will have a plus here and minus here. Okay, because of the current direction in each resistor. I follow this convention. So I name the voltage drop. I will call this one V1, this is V2, this is V3, and this one is V4. And that's it. I have now all the information that I need for writing down the equations of each mesh. So let's start with mesh 1. And I start from this point, for example. I start from here and I go this way. Okay, around, this way around this mesh. And each time I find a voltage drop, I will put in my equation. So I first find VA with the minus sign first in my path. So we'll write down minus VA. Then I continue and I find V1 with the plus sign first. So we'll write down plus V1. I continue on the mesh and I find another voltage drop, V2, with the plus sign on my path. So I put plus V2. And then I am back home. So it's just finished. I just put equal 0. So this is mesh number 1. Now continue with mesh number 2. This one here, this mesh here. And I start from a random point. I start, for example, from this point here. And I go on this direction, and I continue as like this. So I find V3 with the minus sign first on my path. So I put minus V3. Then I continue, I find V2 with plus sign first. So I put plus V2. Then I find V4 with the minus sign first. So I put minus V4. That's it. It's just this procedure. Now I'm just interested in putting all the voltage drop around the mesh with the right relative signs. And now I go to mesh number 3, the big one. So I start from a random point, for example from here, and I decide to go this way. So I first find V1 with the minus sign first. So I write minus V1. Then the turn is of VA with the plus sign first. So I will put plus VA. And I continue the big mesh. This one is the big one. So I find now V4. So I put minus V4. And finally, I find V3 with the minus sign first. So I write down minus V3. So this is all I have to do for solving my problem. This is the first step. I write down the equation following the first law of Kirchhoff of the sum of all the voltage drop in each mesh. Yeah, so this is the first step. Now, in each of these equations, I change where I can, I change voltage drop for a product of current and resistor. So the first equation, this one, will become minus VA, it's just the same as the battery I have here, then plus V1. V1 is given by the current I multiplied by R1. So R1 times I. With this positive thing, because V is equal to R times I. Then I have V2 here. So I put the product R2 times I2. And then equals 0. Second equation, I have minus V3. V3 is given by R3 times I1. So I have R3 times I1. Then I have V2. V2 is given by R2 times I2 here. And finally, minus V4. Minus V4, so minus R4 times I1 equal 0. I will not use the third equation because it's redundant. I can see that this equation is actually the second one minus the first one. So let's see this. We have here minus V3, minus V4, and plus V2, minus the first equation, minus V2. So these keys go away, minus V1, and plus VA, because we subtract the first to the second. Basically, this means that I just need two of these three equations. I can choose the first and the third, the second and the third. I've chosen in this case the first and the second, but they are enough. And I can see this from this system. I have here in this system, I have three equations with three unknown variables, which are I2, and I1. With these three equations, I can find all the currents. And from the currents and the Ohm's law, I will be able to find also all the V, all the voltage drop in the circuit. So basically, with this system, I will be able to solve my circuit. I hope this tutorial was clear, even if it was a little bit long. And anyway, there is another faster way to solve circuit with meshes, and I will show you how to solve this circuit in a faster way in the next video. Thank you for your attention.